Good afternoon, and welcome to our talk on Google Fit Wear and Xamarin. We're going to be covering how to implement fitness experiences on the Android Wear platform using C# and Xamarin. My name is Matt Sullivan. I'm a developer advocate based out of San Francisco, and my area of expertise is predominantly the fitness side.
And my name is Peter Friese. I'm a developer advocate based in London, and I'll be focusing on the Google, on the Android Wear part of this presentation. So back in the day, when you wanted to build a fitness experience, you had to do it all. So you had to build the hardware, and you had to build the backend for it, for collecting the data, for analyzing the data, for feeding it back to the user and providing them with the insights that they were interested in. These days, we've got a lot of mobile platforms and wearable platforms that democratize this experience, because it's so much easier for us now and for you guys today to basically take those wearable platforms and use them to build experiences that you think out. And you can build stuff that's really amazing because you're standing on the shoulder of giants. So you can select any of these platforms to build experiences that wouldn't have been possible before. Because you've got great hardware that includes sensors like GPS sensors, heart rate monitors, pedometers, and more. And we also have open fitness platforms like Google Fit and HealthKit that enable you to feed data into one central repository and then using this data to make it available for the user and for other apps that the user is using to analyze their data, to get insights into their daily lives, and to lead better lives. All of what we're talking about today, you'll be able to experience later in the code lab that's in the Darwin Lounge, and maybe some of you already have been down there to take part in the mini hack. If you finish the code lab that we prepared and a couple of other ones, you'll be able to win one of a couple of devices that Intel is sponsoring. It'll be a couple of Fossil Q founder watches, actually pretty sweet ones. I've got one myself, and it's one of the nicest wearable devices that I own.
So before we kick into the technical aspects of the talk, I just wanted to pose a couple of questions to you guys. Are fitness apps just there for the athletes, for those who are serious about sport? Or to phrase the question another way, is it only there for people who are really trying to stay fit and healthy? Another way of asking this question is, can we add elements of fitness to apps that aren't necessarily focused on fitness itself? So we're not just talking about apps that, like my running app, my walking app, my riding app, my workout app. Can we inject elements of fitness into other areas, other verticals, other categories that you wouldn't normally associate with having a fitness component? So I've got a couple of real-world examples, and I've got a couple of ideas to show you. First, this is the Google Fit app on Wear. It is a challenge workout app where it challenges for you to do a number of sit-ups or a number of press-ups or a number of push-ups in a certain amount of time and a certain amount of repetitions. And what this does is it starts to gamify the idea of fitness. And we see gamification aspects not just in this, but if you look at apps like Zombies Run. How many of you have heard of Zombies Run? Okay, so Zombies Run is a running app, and its key component is you wear headphones, and it simulates you being chased by zombies, which is very motivational. is one way of putting it. But they have a whole story mode, and it gets you to do missions, and it really gets people motivated to run. Runtastic have story modes, and they partnered with the Maze Runner guys, so they have a series in that as well. And what we see is that in order to create motivation for people to use these apps and to stay fit, they're starting to use gaming elements in it. But we can turn that around, and what about a game that isn't aimed primarily at fitness, but has a fitness component? So there's a company called Handi Games. They have a couple of wear games. This is Kitty, my fitness cat. They have Max, my fitness dog. And these are Tamagotchi-style games, where you got your typical, you play with your pet, you wash your pet, you feed your pet. But you have to take your pet for a walk. And in order to take your pet for a walk, you physically have to walk. And there are challenges in there. You have to maintain running at a certain speed for a certain element of time. There are GPS quest locations in there as well. And it's all designed to motivate people using this to actually take more exercise. And it's more engaging to the audience because it's not like, I've got yet another sponge, I'm going to wash my pet. It's going to be, well, I'm going to go out for a 5-minute walk, and it's going to virtually make this pet happier, and it's going to motivate me more to get to exercise more. Games, fine. Games of fitness, we can see that. But then there is retail. So Walgreens, one of the largest drugstores, pharmacies in the US, their rewards card has a health component where you can sign up in your app and you can associate your devices, or you can associate Google Fit or Health Kit. And what it will do is it will give you points for the number of steps you walk. So it's 20 points per mile. You set an exercise goal. You get 250 points when you meet your first goal. And what they're doing is they're adding a fitness component to try and motivate people to live healthier lifestyles. And it fits very well with their sector and their brand, because they want to be seen to not only just be the purveyor of health supplements or drugs or whatnot, but also to motivate people to try to live healthier lifestyles. A couple of other ideas that I thought about that may or may not exist. Imagine a food ordering app. So you got a food ordering app, and it puts your order through to whatever your favorite food provider is. It gets delivered to your door. Great. Well, imagine a food providing app which takes your nutrition into account. So let's say I come home in the evening, I'm exhausted, I sit down, I order a 15-inch pizza, and my app goes, hang on a second, I know what you ate for breakfast and lunch, and I know you're trying to lose some weight. You're over on calories, so why don't you order the 12-inch, or maybe get a side salad as well on top of that? Or let's say you had a really good day and you went to the gym for an hour and a half, you come home and it says, eat some pie, you deserve it. That kind of motivation can help people, not only people who are motivated to lose weight, but also for people who aren't actively trying to balance their diet, but have some sort of sense that they need to eat a little bit healthier. So it doesn't have to be aimed at those who are full on, I'm using a diet app, I'm going there, but for someone who goes, well, I just kind of want to take care of my body, I might eat too much sodium, I want my app to be able to tell me, don't order that, that's a little heavy on the salt, try something else. Another idea, there's a lot of ride-sharing / taxi type apps at the moment. Imagine an app where, for the driver, it tracks their sleep patterns. And what it does is it suggests during the evening or during the morning when they're out driving when they should take a break. Maybe they had a bad sleep last night, so it suggests they take more breaks, or maybe they had a really good sleep so they can go for a longer period. You can use this sort of health and this type of fitness information in these sort of apps. And this is more generally applicable to enterprise areas such as like safety and whatnot for people operating machinery. You could take these concepts and you could apply them to others. And that's really the idea here. You guys, most of you are probably not building a fitness app. But maybe there is an area inside your app that is actually very amenable to having a fitness component to make your users' lives better. And I'll give you this final point. If you're going to have a positive impact on somebody's physical, emotional well-being, then they are going to have a better user experience and better levels of happiness, because they're going to feel that bit better about themselves because of that, because of the physicality that they feel. So, without further ado, we shall jump into the where side of things.
All right. So when we introduced Android Wear a while ago, it started out as a platform that had a lot of potential. And during the past couple of months and years, we've been extending the platform by leaps and bounds. And you're now able to virtually build almost any kind of application that you can dream up for a mobile device for Android Wear. You can build micro applications that run standalone. You can build micro applications that work together with a companion app on the phone. And you can build things like watch faces to actually build things that people will see whenever they look on their wrist. And you'll be able to build watch faces that display useful information on top of the time. And we're talking about one of those useful pieces of information today. So in order to build a Wear application, what you need to do is you'll have a mobile application that will be the container for transporting your wearable application to the end user. So currently, when the user wants to use your application, they will go to the Play Store, they will install your main application to their phone, and then the wearable module that's within the main APK will be transported over to the wearable device. That's how it works today. So if you have an existing application and you want to integrate a wearable module, a wearable application, or a watch face, what you need to do is you need to create a new wearable module in your solution. And this will automatically be included in the main APK. So what you need to do is you need to set a reference from your main module to the wearable module. And the Xamarin build system will automatically take care of integrating your wearable APK into the mobile APK. If you want to build a watch face, as we're going to demonstrate today, then obviously you need to think up how is the watch face going to look like. Maybe you've got a nice watch, mechanical watch yourself, and you want to imitate that, or maybe you've got an idea of how to represent some useful information from within your application. So you need to sit down and design how it's going to look like. And then for implementing this, you'll actually need to implement a piece of code, which is an extension of the watch face service engine. And then to wrap it all together, put this into a companion app. And what's more, in the companion app, you'll have the opportunity to remotely configure your watch face. So all of the watch faces will be surfaced in the Android Wear companion application on your phone. So you can choose a watch face. And then if your watch face has a configuration, then you can configure the watch face from your phone. For example, change the background color or change which kinds of information you want to display. Or you can configure it from your wrist on a configuration activity on your wrist. We'll see how that works in a couple of seconds. Almost every presentation I've done so far has included an architecture slide. So I thought, let's do one here. This is how the Watchface architecture looks like. So on the left-hand side, you've got the wearable application. On the right-hand side, you've got the mobile application. So the most important thing you want to implement is the Watchface engine, which is the box in red. So this is where all the drawing code happens. This is where you'll interface with any other services you want to pull data from. And this is where you connect, for example, to Google Fit. The boxes in yellow are mainly responsible for configuring your watch face and transporting data back and forth between the wearable application and the mobile application. So as you can see, we've got a mobile config activity on the mobile application. and it's connected with the wearable application via a wearable listener service, which is running in the wearable. So they are using the data service API that's available on Android Wear to exchange data from your phone to your watch and vice versa. And also on the wearable application, you've got a configuration activity if you want to configure your watch face from within your watch. In terms of design and what you need to think about upfront when you're developing a watch face, here are a couple of things to think about. Even though most of the Android Wear watches are round, there are a couple of Wear watches that are square. So you need to be considerate when you design your watch face or your wearable applications that there are round watches and square watches. So think of that when you're designing, and later think of that when you're implementing this. And we make available a couple of classes and mechanisms to detect if you are running on a square or a round watch. Also, you need to be considerate of the battery. And because we wanted to take some of the burden of doing battery runtime calculations of the developers, what we did is we came up with this idea of interactive and ambient mode. So the very early Android Wear watches, like the Moto 360, they basically turned off the display entirely when you let go of your wrist. And then when you lifted your wrist, it would turn on the display again. We thought we could do better. So we came up with ambient mode. Ambient mode basically is when your watch face displays a little less information and a little less color, but it's still on all the time. So by reducing the colors and by reducing the number of active pixels on the display, we can reduce the amount of power that's required to drive the watch face. And this is also available for applications. So if you have applications that need to run for a prolonged period of time, for example, a shopping list application. So you're walking down the aisle and you've got your shopping list on the wrist. So you notice, okay, so I need to buy tomatoes. Okay, so walking down to the tomatoes, and then you lift your wrist again to look for the next item. It would be pretty terrible if your application would go away while you're walking. So if you want your application to stay up during this time, make use of ambient mode to keep your application live during this period. Finally, watch faces have the opportunity to be interactive. So for example, if you think of a traditional chronometer watch face, you'll have the main dial, which basically shows the time, and then you might have a stopwatch or a timer or what have you. And as you can see in this animation, there are a lot of other things that you might want to display in what's called a complication in horology terms. So complication just is the technical term for a tiny display on your watch face displaying some sort of information. And we support interactive watch faces, so you can define areas on your watch face that the user can tap on and things can happen. All right, let's have a closer look. So if you implement the Canvas watch face service engine, there are a couple of things that you need to do in order to build a watch face. So first of all, on the right-hand side, you need to do the UI drawing. So you need to manually draw on the canvas object. So it's as simple as that. You just directly draw onto a canvas, and you can use all the primitives that are available. You need to be aware of ambient mode changes. So the system will actually call you and tell you, OK, so we are now in ambient mode, so please reduce the colors, or we are in interactive mode, so you can now use more colors. You need to take care of the redraw intervals. So Android Wear will call you once in a minute. and will tell you to redraw the watch face. So once in a minute, that's good enough for ambient mode because it's good enough to update the time every minute, and then when the user glances at the watch, it's good enough to tell them the time. But if they are glancing for a prolonged period of time, they probably want to see the seconds. So if you notice you're going back to interactive mode, you need to make sure that you redraw every second if you're displaying a seconds hand. If you don't worry, but usually you'll display a seconds hand. So what you need to do is you need to install your own timer which fires every second. So you can redraw the watch face every second in interactive mode. Then there are a couple of other things to be aware of. For example, time zone changes. That's something that you will notice when you're traveling internationally. So when the user lands, then you want to make sure that they are actually in the new time zone. You pick up the time and display the correct time. And then if you're building interactive watch faces, there are a couple of callbacks that you need to implement to react to the user tapping on the watch face. Let's look at an example, and this is the watch face that you can build in the mini hack. So it has the Xamarin logo in the background, and it displays the time, and it's got a step counter on the 3 o'clock position. So these are the hour hands, the minutes hand, and the seconds hand, the hour ticks, the background, and the step count. So in order to draw the background, you just load a resource, and then you will just draw the bitmap on the canvas. Just as simple as that. So it's really, really simple. Now for some scary math. If you want to draw the ticks, you need to get your trigonometry straight. So, sorry, lots of sines and cosines out there. But in the end, if you know from where to where you want to draw, it's, again, just very simply a draw line primitive that you use in order to draw the ticks around the watch face. For the step count, it's even simpler because as soon as you know where to display it, it'll be just a draw text. So you can display any information just if you want to represent the text by doing a draw text at an X and Y position. Ambient mode. So this is the official watch face on the Tag Heuer device. So on the left-hand side, you'll see how it looks like in interactive mode. On the right-hand side, it's in ambient mode. And you see that they reduce the amount of information that is displayed. So a lot less ticks, for example. The colors are reduced. And in general, the watch face is a lot more darker. So a lot less pixels we need to turn on. So massive battery savings there. Also, it doesn't display a seconds hand. So the thing with the red arrow on the end, that's a GMT hand. So it's not a seconds hand, it's a GMT hand which shows the second time zone. But you'll notice in the left-hand picture, the seconds hand is at the 2 o'clock position, and in the right-hand picture, it's gone. So no regular updates for the seconds in ambient mode. So in order to implement ambient mode, this is part of the onDraw method. Basically what you need to do, you need to figure out, am I in ambient mode? And if so, just don't draw stuff that you don't want to be visible in ambient mode, and that's it. The other thing you need to do in ambient mode is to switch between secondly updates and minutely updates. So this is how the timer is configured, and the part that's highlighted currently is the part of the code that will actually call the draw method. So when the timer kicks off, it will invalidate the screen, thereby forcing the draw method to be called. And this part of the code switches between updates per second and turning the timer off, and then actually you receiving the callback in the onTick method. As I mentioned before, you can configure watch faces. So if you long press on on the watch, it will actually display the watch face picker, and there is a cog just below the watch faces, and you can press on the cog, which will open a configuration activity, just as you can see on the watch here. And on the mobile device, you go into the Android Wear application, and then it shows a list of watch faces, the current one being highlighted, and then it has a cog as well. You press the cog, and it will display a configuration activity. And those two should be synchronized, obviously. So whenever you configure something on the watch, it should be reflected on the mobile and vice versa. So you need to synchronize this piece of information from your phone to the watch. And this is where the data layer API comes in. So this is how you will synchronize the fact that the step counter should be displayed or not in the sample watch face. As you can see, we're assembling a data map request, which basically is just a glorified hash map, which can be serialized via the data layer API. And then in the last line, we're basically sending it to the data layer for Android Wear to send across the wire. One thing I'd like to highlight is the second last line with the set urgent call. This is another optimization. So if you put something into the data layer, we'll make sure to synchronize it. But this might take up to half an hour for performance reasons. So we're batching those updates. If you have something that is urgent and you really want to ship this update right now, as for example, something that needs to be reflected in the UI, then you need to switch on the set urgent flag, and this will make sure to synchronize straight away. Yeah, this is the URI path and the step and the data item key, so you'll know where to find those pieces of information later on when you read the map request. And this is on the other end, on the receiving end, basically. So the receiving end will get a callback whenever the data item is called, and then you'll go in and read the data map to find the piece of information and then do whatever you need. And in our example, we update the watch face in order to reflect that change on the watch face. Okay, so to summarize, you implement the watch face drawing code, and then you have a place in the code where you have the Google API client that you need to talk to fit, which Matt will talk about in a minute. You have configuration code, and you have code for accessing the step count. So there's a lot of things going on, and you can imagine that this might end up in a very long file. And we don't want to have spaghetti code. We'd much rather have lasagna code. So here's how you can do that. We'll just use partial classes. So all of those things that need to go into the Watchface engine, we just split out into partial classes. And then, for example, for the main drawing code, we will have one partial class. For the configuration stuff, we'll have another partial class. And for the API client as well. And this will result in very small files that have just one aspect. They're dealing with clean separation of concerns, which is really nice. All right. And with that, I'll hand over to Matt.
Thank you. Google Fit. Here we go. So Google Fit is a platform for managing health and fitness data. And it gives you two key things for this talk. The first is it gives you access to sensors, not just on device, but also sensors that might be hooked up to the device wirelessly. So for example, I could have a heart rate strap on, which I can hook up either to my phone, or I can actually hook it up directly to my watch as well, if needs be. And I can read this data in real time as much as the device can sample it. The other thing it gives is a data store. And apps or services can write into the data store and read data from the data store, subject to user permissions. And that's really important because we take user privacy very seriously. And so we compartmentalize different types of data into different permissions buckets, and you will always need to get the user permissions to be able to access that. The other thing that we do on the data store is that we don't simply suck in raw data and give you raw data back. We suck in raw data, and you can read the raw data back if you want, but what we do is we also normalize and aggregate that data. So if you're like me and you've got your watch tracking your steps and you've got your phone tracking your steps and you happen to have another like pedometer device as well, all of these devices can be feeding data into the FIT platform. And what it will do for you is that it will make a best effort to extract the most accurate data it deems from all of those data points. And then you can say, give me my step count for yesterday, and you will get that data back. You don't have to do any of that munging of data together yourselves. And that becomes very important and makes your lives much easier. So the permissions. There's activities, there's body, there's location, and there's nutrition. Activities are like, I went for a run, or I biked, or I did push-ups. Body is, for example, my heart rate. We store location data as well, and that's because apps like running and riding will use GPS data to track where you went. So we make it available through this as well as through the other standard geo services. And more recently, we added nutrition data, which not just captures what you eat, but also captures its fat content, its sodium content, its whatever other type of vitamin, mineral, or other such in there as well. And so you must ask for each one of these that you need, and you can ask for read or read write. So you can be very specific about what you ask your user for, and I would recommend doing that so you don't ask for too much. All the different data types we currently support, and we're adding to these all the time. We've got calories and nutrients and nutrition. We've got a bunch of physical data, such as height and weight and heart rate. Bunch of activity data, steps, calories burned. There's about a list of 100 different types of activities that you can link to. And we track sleep as well. And we don't just track sleep duration, but we track the types of sleep you have. So it could be light sleep or REM sleep or deep sleep. And all of these data points you can write into the system, and you can aggregate around all of these data points as well. On Android, there are 4 main libraries. I'll go through each one really quickly. Sensors is all about getting real-time data. You want real-time data, you want a user's heart rate. This is what you're going to use. You can look for what sensors are available, both on-device and wirelessly connected to the device. You can register for listening to that data. You'll get it in real time after that, and then you can remove it from there. If you want real-time data, the Sensors API is where you go. The Recording API is all about recording data into the FIT platform on your behalf. If you have a walking app and you want to record a user's walking throughout the day and report it in intervals throughout the day when the user opens the app, you will ask the system to record the data. This will not give you data in real time. You won't get a feed of data. But what you can do is later on you can query back into the system and go, well, tell me about the user's steps. Because FIT will only record user data if you ask it to. So Recording API is to make sure that that data is captured on your behalf. This is how you get to the data in the History API. You can manually add data in there if it's not being recorded by sensors. Typically, you'd see a lot of this for like nutritional data and data that can't be captured. You can delete data only that you have captured or written in, and you can retrieve data. And you'll see an example of this later on. Retrieving data is all about normalized aggregated data. So what you write in might not be what you get back out again if you ask for data in a normalized way, because there might be multiple different data feeds going into the system for those types of data, step count being the most common one for that. And finally, the Sessions API. We can capture the idea of sessions. That means I go for a run. When I go for a run, I might be running for 10 minutes, I might be paused for 10 minutes, I might be jogging for another 15. These are all individual activities, but we can capture these in the concept of a session. A gym session, a bike riding session. What it does is it allows you to capture a workout for a user, is the best way of thinking about it. And within that workout, there can be multiple different types of exercises or activities. And it's nice because then you can nicely report these back to the user, and other apps can pull this out as well. And they can see it. Android isn't the only way to get it. We have a full-blown REST API. This is a curl command, which is a bit much to take in, but this one command will pull out a user's aggregated or normalized data steps for whatever those two time points represent. It's a great way of being able to do server-to-server communication. Some people who work on Google Fit will do the authorization on the phone, will get the appropriate OAuth tokens, will pass the refresh and access token back down to the server, and then from there on in, they will start to pull data back and forth between the system. It's a great way of doing it if you're not doing real-time stuff and you do a lot of analysis in the background, and you don't want to worry about, is the phone on, is there reception, when did I last get my data, et cetera, et cetera. You can just pull it straight through the REST API, and even though this looks like a bit much to swallow, this is you can type this in Linux, and as long as you have the appropriate access token, you will get the appropriate data back out again. But I won't dwell on the REST API. Just suffice to say that it's there, and you can do 90% or more of what you can do on the Android SDK. So I'm going to very quickly run you through some code to show you how to read steps from the system. There's a few steps to take. We've got to create a Google API client. We've got to make sure we're recording the steps. We're then going to build an aggregated query to pull it, and then we're going to read and extract the data. So there's 4 bits we need to take into account. So building the API client, if any of you have used the Google API client before, this is going to look fairly familiar. Suffice to say, we're asking for access to 2 APIs. There is a scope in there which indicates what we're looking for. Now, I've been bad here because I've asked for both read and write on the activity. I'm only wanting to read the steps. That should really be scope activity read. And before, when you used to build the API client, there used to be a lot of boilerplate around the onStart, the onResume that you had to put in and take into account. The enable auto manage now handles most of this automatically, and so this is all you need to do. Now, you'll notice that when we get to subscribe to steps and read steps, the system may not have actually connected to the Google API client yet. It might not be available. But because we're just reading, that's OK, and the system will take that into account. So I don't have to do any callbacks here to worry about, am I connected, am I not connected? I simply do the connection attempt. I handle the error if there is one. Otherwise, I go, tell me what the steps are, and the system will do that once those steps are available. Subscribing is pretty easy. We make a call to the recording API. We do subscribe. If there's a problem, we handle it. Other than that, we're done. The system is now recording steps on our behalf into the Fit platform. The data read request shows the flexibility we have in terms of being able to query the system. So as you can see, we're setting a POSIX time for midnight tonight, POSIX time for midnight a week ago. One of the things you need to take into account yourselves when you're querying data is that it won't, if you ask for a 24-hour period, bound you on the midnight. It will be 24 hours from where you have the start and end times. So you need to work out what those time intervals are. And then when we build the request, you see there's a data aggregation parameter. And what we're saying is we're looking for step counts, type step count delta. We're going to aggregate on step counts. We're going to bucket, please bucket my results in days, and 1 per day, please. And then between these 2 time ranges. So what this is going to give me is from midnight until midnight a week ago, I'm going to get all of my steps bucketed by each day. You don't have to do anything else. You can now read through the buckets. You can go today, yesterday, the day before that, the day before that. You don't actually have to go and process this data yourself. And you can do this in minutes or seconds. And there's other aggregate filters you can put on that to change the data around as well. So you've got a lot of different ways. You can make the system do all of the processing for you on all of the different data types that we have. So finally, we're going to read the steps. We're going to take our request. We're going to ask the history API to read the data. It's going to come back in buckets. And then this 5 or 6 lines at the bottom is just unwrapping the buckets. Inside a bucket, there's a data set. Inside the data set, there are data points. And those data points may have 1 or more values. This all unwraps very neatly to give us, effectively at the end, a step count per bucket, which means the step count every 24 hours. So now you have gotten step counts out through those 4 steps. The only caveat here is when you're writing data, you follow the same principles, except that when you're creating the Google API client, you must be connected first. So you're going to have to wait for the callback to say that you're connected so that you can write. Because if you try to write and it's not connected, it's all going to blow up in your face. So that's great. There's a lot of steps. There's a ton of code to do that. What if you just want to get today's steps? I want to know how many steps I've walked since I got up this morning. Well, fortunately, there's a much easier way of doing that, and this is a simple way to start, and it's what we've used in the code lab. You don't have to build an aggregated query. We have one call, which will be read daily total, which will give you that. And you need to follow these 3 steps today. But shortly on a new release of Fit, we're going to remove the necessity for recording steps for step count, just because pedometers are constantly tracking these things, so we're always recording them. You don't need to do that. Removes it down to just creating the client and reading the data. And this is all-in-one code to do it. The nice thing about the read daily total call in the history API is that you do not need to be authenticated. This is the only call in Fit where it does not require user authorization and will only give you the step count on the device. So we use get default account. It makes it that simple. We connect. Then we call read daily total. We do the same unwrapping, only this time we get back its single data set for the day, and you have your steps. So in the space of 9 or 10 lines of code, you're able to pull out the step counts in their entirety. So again, this is demonstrated in the code lab. Please pop over. We can answer any other questions you have on things like that. But other than that, thank you very much. And we have time for 1 or 2 questions.
Yeah, we've got a microphone over there.
Something I've always thought about is data syncing from different sources. It seems to work, but I've got a lot of time. I may have another fucking stack calling something with GPS, and they both log a workout session as once. Is there anything to the source there that does it, or not? Because it does seem to, there never seems to be duplication of data.
The Fit platform itself dedupes data. So if multiple types of overlapping of the same data is overwritten, we do a best effort to deduplicate that. And sure, sometimes that can go a little wrong, but over time we've improved that consistently in the back end. The only thing to take into account as well is that when you sync with multiple devices connected to Google Fit, our syncing is never instantaneous because we're always worried about, like, we're taking into account battery life and connectivity and blah, 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 blah. So the data will eventually sync up. So one of the interesting side effects is you might record something on your phone in terms of steps and whatnot. Another device might query the platform. It'll get a result, and then an hour later, that result might update to something different because it will have gotten more data in previously. So you may see some modifications there. But we really make we put a lot of effort into making sure that when you query data, it's our best estimate for what you're doing without having to worry about duplicates. Any other questions? No? Well, thank you very much.